Hey guys, so today we're going to be solving around 200 questions. But before that, let me just take a minute. Okay, so today we're going to be doing 200 programming questions in C++, and we're going to go topic by topic. Beginner to advanced. We're going to cover 1D arrays, 2D arrays, strings, functions, parameter passing, inline functions, macro functions, and a little bit of recursion. So let's start with our first program here. And we're going to start by writing what we always write when we create a C++ program. Um, these two lines, we often write this again and again in any C++ program. And then we'll create the main function. And the question here is to find the largest element in an array. So let's first create an array. I'm going to create an integer array named A. And we're going to give it a couple of elements. Let's just give it 10 elements here. And then we're going to put an int max. We'll set it to a of 0. So essentially in this line, what we're doing is we're making max, which is the um, essentially our largest element. We're assigning the first element to that by default. So after that, we'll start a for loop to go through the array. Now there's a little trick here that I wanted to show you guys. And essentially, instead of writing 11 here, or actually 10, um, because we need to go from the 0th element to the 9th element. A little trick I like to use to make your code sort of reusable. So if I want to change the number of elements here in this array, I'll have to change the number I put here in the for loop, right? So essentially, what I can do is I can use the size of function and take the size of the array and divide it by the size of each individual element inside the array. So a of 0 in this case. I take a of 0 because that's the smallest an array size can be. Then we'll hit I++. So then we're iterating through every element in the array. And now if a of I, which is our element, we're gonna go from 1 to 2 to 3 to 4 to 5. Sorry, 0 to the ninth element. So if any one of those elements is greater than max, then we'll simply make max take the value of that element. So essentially, if I have over here, all of these numbers are in ascending order, right? So if I have 1, so max will be 1. So as soon as it goes to the second element, the second element will be greater than max. So since it's larger than max, it'll assign the second element to max itself. So now I'm basically noting every integer that's bigger than max. And I keep on doing that until I have the largest element in the array. So now all I can do is hit a cout here, print the output to the user screen. So the largest element is, then I can simply put max here and use endl, which is the end line, and return 0 because we have infinite. So that's our first question. So this is how to find the largest element in an array. Now let's do the smallest element in the array in an array. And that's not quite difficult. It's quite similar. So we do the same thing again. create our main function here. Then int a is equal to, and we then initialize the array with a couple of elements again. So we did the same thing. The loop is exactly the same as our previous question, and the only change here is that we'll have to actually, it's better to name this instead of max, we name this min because minimum, we want to find the smallest element. So if a of I, which is the element, is less than our minimum value, then we'll simply make the minimum value the a of I. Now, all we have to do is simply print it again. And then return 0. It's as easy as that. So that's how you find the smallest element in an array. Now, how do you reverse an array? Just a second, guys. Okay. Now, this is also quite similar. Again, we create the main function. Oops. Return 0. Okay, now let's create our array. I think it's important that we print it here for this particular question so we can actually see that the array has been reversed. So let me just print this. Again, use the size of function to do it. Just like so. And now what we want to do is we want to reverse the array, and you can simply do that by rewriting here, reversed array. Why don't I write original array at the top? You can copy the same loop, but we have to make a few adjustments here. Now, over here, we need to make sure this is initialized to the actual size of the array. So we want to start with the last element and then make our way down to the 0th element right here. So we know that it's going to start with the 9th element, right? So essentially, what do I have to do here? So this will actually give me the size of the array, and this is basically equal to the number of elements we have inside the array. But we don't actually want to start there because it'll go out of bounds, right? Because this goes from the 0th element to the 9th element. If I put a 10th element, it'll simply be out of bounds. So all we can do is we can make a slight adjustment to this. We can essentially put int I is equal to size of a minus 1. Size of a by size of a of 0 minus 1. So that gives us the last element of the array. And now we have to actually work our way down to the zeroth element. So how do we do that? So what we do is we put I is greater than equal to 0. That means this loop will keep on running until this condition is false, and then the loop will just simply stop. So uh, how do we then make it keep on, go backwards? We simply have to subtract it, right? So how does a for loop work? Let's just remind ourselves that. So first it starts by executing the first statement here, and then it immediately goes to the condition. If the condition is true, it will run this code over here and then run the third statement. So essentially what we want to do is as soon as we run this code, as soon as we print the final element, we want to subtract the index by 1. So instead of incrementing the index by 1 in this case, we have to simply subtract it, and we can use the minus mice, the decrement operator for that. And it's as easy as that. So let's try running this once, shall we? Yeah. Okay, so there's a slight issue here. Let's run that again. Yeah. As you guys can see, we have successfully reversed the array here. Now let's go to the next question. If you guys have any questions, feel free to put that in the chat. Okay. Now the next question is sum of all elements in an array. Now this is quite simple. So again, we start our C++ program the exact same way. So let's create an array. Now we're going to create an integer called sum and initialize it to 0. Then we can start our for loop and use our sum size of trick again, sorry. Then we simply have to add every element to the sum variable. So all we have to do is put sum plus equal to, then a of I. Then all we have to do is simply print sum. Now, why don't I also print this array so that it's easier to understand? I can actually do this in one loop. Just run it once. Um, yeah. So as we can see, we have the array printed here along with the sum of all the elements. So the program is working. Let's do the fifth question, and that is count the frequency of each element in an array. So what exactly does that mean? So let's just first of all write. Now for a given array, the frequency is the number of times an element is repeated. So let's say if I have 5, 10, 15, 20, 5, 25, 30, 15, 30. So if you have these elements in an array, the frequency is simply the number of times an element is repeated. So the frequency of 5 here is 2, the frequency of 25 here is 1, the frequency of 15 here is 2. So I hope you're getting an idea of how we have to approach this question. So let's again create an integer called frequency and initialize it to 0. Now here we're going to have to take a user input because we have to ask the user which number they want to essentially, you know, find the frequency of. But in this case, I'm going to show you how to find the frequency of each element. Okay? So we're going to create an array of Boolean variables. And essentially, we're going to make sure that the size of this array is the same as the size of our original array. So that's how we do that. And essentially, we'll then say it's equal to false. So we're initializing all the elements inside the array to be false. Now let's find the frequency of elements, right? We'll create a for loop. Now, if you another interesting trick. So over here we're using the size multiple times, right? So what we can also do is create an int size here and essentially give it this right here. So essentially what I can do is I can just write size here the next time. Or if you want to take a smaller variable name, just put in. Mm, that's interesting. Okay. Anyways, um, coming back. So, okay, now essentially what we need to do here is count its frequency, right? So if um, the element visited is equal to true, so essentially we're making sure if the value of a given element has already been visited, then we'll simply continue. We'll skip it. Now we're going to put in count is equal to 1 because for any given element, because we're counting it for a given element. So for in, let's take another variable. Since this is a nested loop, we cannot repeat the same variable names. So essentially what we want to do is put in j is equal to I plus 1. We want to look at the next element and we want to make sure j is again less than n. Now n is the size of the array, as you guys can remember, and then simply hit a j plus plus. So essentially what we're doing is for a given element, let's say 5 here, we're looking at all the elements ahead of 5 and we're trying to see if 5 exists here. So as we can see, 5 already exists here. So that's exactly what we're marking. So let's continue with this. Now, just before the loop ends, let's just print how many times a given element was found. So the frequency of each element. So the given element in this case. So a of I, we're going to print that and just print to here, then count, and then add times, and then go to the next line. Now that we're done there, let's just add a semicolon here and then again return 0. So let's try this out. So let's see if this is correct. So we know 5 repeats 2 times here. That's correct. 10 is repeated 1 time. 15 is there at 2 different indexes here. So 15 exists like 2 times. The frequency of 15 is 2. 20 is again 1. 5 has already been repeated, as you guys can see. So we're not going to count 5. Then 25 exists only 1 time, and 30 is twice, here and here. So that explains this program. So you just finished the 5th program. Let's move on to the 6th now. So again, we'll start our program with the same 2 lines. Create the main function. Now the next question is binary search. Now this is a very interesting concept, and you should really know this. And let me explain what exactly binary search is. So binary search is a searching algorithm used in arrays. So let's say I want to find an element in an array, and we just did that. We did like a similar question just a moment ago with frequency, but let's say I just want to find an element in an array. How would I do that? Now, let's say if I have an array A with the following elements, and let's just iterate through the elements of this array. So I'll start a for loop, initialize the variable I to 0. So the first element, we say I is less than size of A by size of A of 0. So essentially we're calculating the number of elements in the array and then going I plus plus. Then we're going to say if A of I is equal to our target number, the number we want to find essentially. So we're going to say target. We're going to say the number has been found. And then we'll break. Essentially break just stops the array. Now over here, let me just initialize an int target. And why don't we take the value of target from our user? So cin target. So this is essentially taking an integer from the user, and that's the integer we're going to search for in the array. So I'm just going to quickly ask the user to input a number. Okay. So let's just run this once. So I'm going to search for the number 6. Now we know the number 6 exists here, right? Um, okay, that didn't work. Right. So just be a little careful here. Whenever you use um, an if statement, if you have a single statement to write within an if or a for loop or an if statement, then you can simply use indentation. You don't need to use brackets. But when you're using more than one, it's very important to use brackets. So that's a mistake I just made here. And this should work. So as you can see, the number has been found in the array. So now, how do you think this is working? So essentially, the integer I is first pointing at 1, and then we compare it. to our target number. So target number here is 6, right? So is 1 equal to 6? It's not. So then we go to the next element. Is 2 equal to 6? It's not. And it keeps on going until we actually reach 6. So it's already ran around 5 times, and it's on the sixth run when it actually figures out that, hey, this is my number. But what if 6 was located here? Isn't it like running through every element in the array before reaching 6? So it's running 9 times before the run, where we find where we actually find the number. So is there a faster way to do this? Because it's essentially running through the whole array. Well, there is, and that algorithm is called binary search. Now, how does binary search work? So binary search requires you to have an array that is in ascending order. So all the numbers need to be in ascending order. You can't have like 6 at the end of the array because obviously 6 is smaller than 9. So let's just put this back into ascending order right here. So these numbers are perfectly in ascending order. Now let's use binary search to find an element. Okay. So we're going to use a function for this. So we're going to call it int binary search. We're going to take in an array as an input, and we're going to take an integer n and a key. Now we'll just look. I'll just explain each of these to you in just a second. So first we start with int low. We'll initialize it to 0. Now let me explain how binary search actually works. So binary search works by finding the middle element. And since the array is in ascending order, now let's say we want to find 3 here. So essentially what binary search does is it goes to the middle element. If the middle element is greater than the number we want to find, and since we know this is an ascending order, we know that the middle element is ahead of the element we're trying to find, right? If we're looking for 3 and this is an ascending order, we know 6 is going to be ahead of 3. So what we do is we look at the middle element, we compare it, and then we close the rest of the elements. So since we know in this case that the element we're searching for is 3, which is less than 6, we can then ignore the elements that are greater than 6, and of course 6 itself. And then we can look at the middle of the remaining elements. So the middle of the remaining elements would be 3. And there, we found 3. That's our number. So that's essentially how binary search works. So let me just show you the implementation for binary search. So are you guys understanding why low is less than equal to high? Have you guys understood that? Okay. So if A of mid is equal to key, what does this exactly mean? It means if the middle element of our array is the number we're trying to find, we will return that number, that index. If not, then we'll essentially check if the element is less than key or the number we're trying to find. In which case we will say that low is equal to mid plus 1. Now, when we hit return, this will immediately return a value and the function will stop. However, if we hit low is equal to mid plus 1, it'll essentially go back and like the loop will repeat itself. So we'll have another run and it'll go on until it finds the element. Now, if the element is truly in the array, then it'll immediately be returned when it's found. The index will be returned when it's found. However, if it's not there, we want to return something that lets us know that yes, the element does not actually exist in the array, in which case we hit return -1. That's a common index we use to say that an element does not exist. Now, what do these mean? So essentially over here we're sending an array, we're passing an array into the parameter, we're passing the size of the array n, and key is essentially the number we want to find. We can also name it target if we want. Over here I've named it target. So how do I actually now call this function? So since it's returning an integer, which is the index, I can simply go out here and print the number. Um, Actually, we should check if the number actually exists in the array. So what happens if the number doesn't exist in the array? We return -1, right? So if binary search, we'll open the bracket, input our, we'll sort of assign our variables, a, then we have the size, which is size of a divided by size of a of 0. And then we can simply, um, then it's the target. Now, if this is equal to -1, the element does not exist in the array. Else, if it does, then the element exists at the, then we'll basically um, put the same thing here because this is going to return the index, right? So we're putting the index and then adding 1 to it because that's the position, right? Or if you simply want to put the index, you can simply put it as so. And just like that, we have binary search. This is a little bit advanced, but it's very important to know this concept. So yeah, let's just run this once. So let's find the number 6, or let's do 2. So it exists at the first index of the array, which is correct because this is 1 is at 0 and 2 is at 1. So this is how to do binary search. Now let's do the next question. Again, write the two lines. We're going to create an array again. Now this question is to check whether a number, whether an array is sorted or not. Now how do we exactly do that? Well, it's quite easy as you guys can guess. So essentially we take in, so IO stream, so IO stream is essentially a header file. IO stands for input and output. So it basically provides the functionalities for the input output operations. And what does that essentially mean? So do you remember seeing C in over here? C in and C out. So essentially C in is used for input, and that input is usually from the keyboard. So the IO stream imports these functionalities into our program. It lets us take input from the user and it allows us to display an output to the console. So that's a really interesting question, what exactly IOStream is. So it's a header file And it essentially allows us to do various different things, like print a number or take an input from a user, and the endl, which is used which we use in our program here, that is also a part of our IOStream library. So it's really interesting. That's a really good question. Okay, coming back to our question. Yes. Um, okay. So check if the array is sorted. Now, how do we do that? So essentially, this is quite simple. We just have to check if a given element is less than the next element, right? The array essentially just has to be in ascending order. So all we have to do is, I'm going to use functions here because it's important to use functions. So an important part of object-oriented programming. So here we're going to use a Boolean function, a bool function actually. And bool stands for Boolean, and that is essentially a data type which can either be true or false. So we're going to use bool, sorry, and we're going to name the function is sorted, and we're going to take the array in as a parameter, and then take in the size of the array. Now we're going to start a for loop and put, again, do our usual. Now over here we're going to create an if statement, and if like the if our element, which is the zeroth element, which are like the element our index is pointing to, is greater than, like, you can also do it the other way around, is less than a of I plus 1, which is essentially the next index. So what are we doing here? We're checking if I, like, 1 is next than the, like, an element is less than the next element. But over here, I'm going to take it the other way around, because then I can immediately say that it's false, that the array is not sorted. It's not in order, ascending order. So if this is the case, if the element we're looking at is greater than the next element, we immediately know that the array is not sorted. So we're going to immediately return false right here. And if the loop ends up running without returning false, then we'll simply return true. Now coming back here, we're simply going to put if is sorted. Now remember, if statements, how are if statements written? Well, we write if, we open brackets, and we put a condition here. Now condition can be a statement that is either true or false, right? Like I can put 5 is greater than 3. Is that true or false? That's true, right? 5 is greater than 3. Now, if I say something like 2 is greater than 3, now we all know that's false, right? That's preposterous. So essentially over here, we put a condition. And if the condition is true, then we can run a certain block of code. So we're going to put our condition, since Boolean over here, our function over here returns a Boolean, which is again true or false. We can actually substitute it and put it in the condition, because the condition is true or false. And our function is returning a value that is either true or false. So we can immediately put it right there. So we can put is sorted and then put pass our array and its size. So size, again, we can do the same thing. And actually, now that I think about it, we could have just used n here. Um, size of a divided by size of a of 0. Now, if you guys haven't understood this, do let me know. Essentially, what we're doing here is calculating the size in bytes of our entire array and then divided by the size of each element. So that will give us the number of elements in the array. It's a very neat trick, and it's very useful because it gives us a bit of flexibility. Because if we use a fixed array, let's say we have a question that use create an array of 10 integers, and then check if that's sorted or not. And then later, let's just say we switch it to 5 integers. Then we immediately will have to change every number here from less than 10 to less than 5. and that can be troublesome. So we just use the size of, um, size of function. Can you please explain line number 4? Okay, yeah. So this is essentially the syntax for a function. Now, a function is simply a block of code, and functions are basically used to make like code more readable, and that can take us a really long way. And it also saves time because we can repeatedly do the same thing again and again. Functions make our life easier. Now, how do we write a function? Let me show you the syntax for it. So, a function, we start with our data type, then we write the name of the function, and then we can pass parameters. Now, parameters are simply inputs we can give the function. Now, let's say I want to write a function to print my name. Okay, I can essentially put void here. Void is a data type, all right? I can put other data types as well. I can put an integer, I can put a float, but I'm going to put void here. Void basically means I do not have to return a value. Okay, and we put void, and then let's name this function. So let's call this my name, and then I'm going to pass a string s. Okay, now what I'm going to do is I'm going to simply put cout and print s. Have you have you understood this? So void here is the data type, my name is the name of the function, and string s is essentially a string I'm giving to the function to work on. Now let me just take an input here and show you how this actually works a bit more in detail. Just gonna comment these lines. So let's just say string str, and then we're gonna take an input from the user. So I'm gonna be giving this a certain value and then enter a string. Okay. Now I want to print my name, right? So what I'll do is I'll simply call this function, and I can call it simply by its name. So my name, and then I have put a parameter here, right? What is now you have to look at the data type of the parameter given. So over here it's a string. So I have to make sure I actually give this a string. So I have a string here called str, right? So I'm going to pass that through. Now if I don't pass that through, it's not going to work. Or let's say I take an integer a here. Okay. If I decide to put a here, which is an integer, it's wrong because as you can see, it's even showing me over here that it's wrong because it's converting from, it's we're trying to force an integer where the computer is expecting a string, and a string is, an array of characters. It's a character array. So that's wrong. So you want to give it a string. So let me just run this once. So what this will essentially do is it'll copy paste everything here over here. So it's putting this entire block of code and running it instead of our function call. Okay, have you understood that? I hope you're understanding that. So line 4 here is essentially, again, it's the syntax for a function. This is how you write a function. You have a data type, you have a name of the function, and any parameters if there are any. Let me just run this once. So okay, we have an error here. Uh, okay, because I commented this. Um, just gonna comment this entire function. Yeah, let's just run it one more time. Um, yeah, let's enter a string. So I'm going to put my name, Agastya, and there, can you see it? It printed Agastya. Now, a very useful thing is you can call functions again and again. So I can make it write my name as many times as I want. If I wanted to write it 3 times, I can simply do this. So if I write my name here, it printed it 3 times. So that's how you use functions. And like I just said, this is how you write one. You write the data type, You write the name of the function and if there are any parameters to be given. You've understood? Excellent. Coming back, we're gonna move back to our code here. So we were checking if an array is sorted or not. Let's see how that works. So we've called the function, and now if it's sorted, we can simply write here that our array is sorted. And if it's not, we can, since there's no other possibility, we can simply write else here. The array is not sorted. Let's try this out. Uh, um, 24, right? No semicolon. Um, once. Yeah. So we know the array is not sorted. I don't think that was right. 1, 2, 3, 4, 5, 6, 7, 9, 10. That is correct. If a of I is greater than I plus 1, return false. Uh, Indentation is correct. That seems to be correct. Ah, yeah. And minus 1. Of course. Um, right. There. So my mistake over here was simply that I let it run out of bounds. Now, over here, I'm trying to access the element I plus 1, and I is running, was running till the size of the array. So till the ninth element. So I plus 1 will give the 10th element, but the 10th element simply does not exist. So that's very important. So that was a small mistake, but now that's done. Okay, simply just change that stuff. We now move on to the ninth question. Eighth question, my bad. Just gonna take a break. Okay. What is our next question? Um, okay, so we have to rotate an array by k positions. Now this is too difficult of a question to be starting with, so let's let's try a different question. Mm, okay, write the sum of even numbers in an array, of all the even numbers in an array. This is an excellent question. This is something you can expect in your exams and it's commonly asked. So let's start by including our these two important lines here in main. Okay, now let's just create an array. Again, 1 to 10. Now let's see. Now what do we have to do here? Essentially, we need to basically add all the even numbers in an array, right? So essentially what we can do is we again create an in-sum and initialize it to 0 because we've not really counted any numbers yet, right? So we're going to start by 0, start a for loop, and there's actually a bunch of ways you can actually solve this question, some better than others, but I'm going to use the standard answer right now. So now again, size of a by size of a of 0. This gives us flexibility with the array size. So I can essentially just change the number of elements here at the initialization and the rest of the code will work perfectly. Now we've tried an if here, and if the element at the ith position, the index I, is an even number. So how do we know if a number is an even number? Now we do a of I mod 2, and if that is 0, then it's an even number. Now have you guys understood this, or should I explain it? Should I explain this, guys? Okay. Well, I'll just explain it anyway. So the modulus operator here gives us the remainder of a division. So over here, we essentially divide it and then we check the remain. It gives us the remainder, right? So now, what over here, if let's say of a of I over here is 4, okay, our number is 4. Now what we're doing is we're dividing 4 by 2. And when we divide 4 by 2, we get a remainder 0, correct? Now, if we divide 5 by 2, okay, you want me to explain? Yeah, so when we divide 4 by 2, we essentially get 2, right? Now, if we, the remainder is 0 because it's divisible. However, if we take a number like 5 by 2, we're going to get the remainder, we're going to get the number 3 because, no, 2.52. Yeah, this is an integer, so it'll be 2. Don't confuse yourself over that. But our remainder here, 5 divided by 2, the remainder will be 1. So essentially, if a number is divisible, the remainder will obviously be 0. So that's exactly what we're doing here. Now, if I want to find if a number is divisible by 16, all I have to do is change this from a 2 to 16. So I hope this is very important because the same concept can go with like many different questions. So instead of 2, 16 can give you like you can check if a number is divisible by 16 by just replacing the 2 with a 16. So now anyway, we're finding even numbers. So all even numbers can be divided by 2. We know that. So if the number is even, then we simply add it to our sum variable, and then at the end of the loop we simply print it, just like so. And then again, don't forget your return 0, and let's just run this once. R30 there. So if you want to verify this, 2 plus 8, 10, 4 plus 6, 10, and then 10 itself. So that's 30. So have you guys understood that? That's how you find even the sum of even numbers. Now, if I wanted to do the sum of odd numbers, it's not that difficult. All I have to do is, instead of it being equal to 0, I just have to put an exclamation mark. Now, an exclamation mark and an equal to essentially means not equal to. So if the modulus is not equal to 0, that means if it's 1, which is the case for odd numbers, then it'll add the number to our sum. So essentially over here, what we're doing is we're checking, like this will give us the odd numbers now. If I put not equal to here, and equal to will give us even numbers. It's quite simple. It's the same code with just a minor adjustment. Okay. So that's two very important questions that can be asked. Is that clear? Okay. Now let's move on to two-dimensional arrays. I won't be able to solve 200 questions this time, but let's aim for 200 questions solved, completely for this entire series, hopefully. So let's just name this Q. So this should be 31 if I'm not wrong. Yeah. Okay, so let's do two-dimensional arrays now. Now, two-dimensional arrays are as good as matrices, which you must have already heard of, and if you must have encountered somewhere in maths. So let's first of all write what we always have to write for a given C++ program. Okay, let's just start by the array. So to create a two-dimensional arrays, I need usually we put the size of an array here, right? If we're just declaring it, we put a size here within this within these square braces, and we get the size of the array. Or I can directly just initialize it and give it values. Now, for a 2D array, we can do the same thing. We can initialize it, but for today, let's just work on declaration and then take the input from the user because that's something that's often asked for two-dimensional arrays. So first, it's split into instead of just being the length of the array, it's now rows and columns, the number of rows and the number of columns. Let's take a 3 by 3 matrix here because that's very commonly used for programming. 3 by 3 matrices are people's favorites. So this is just declaring it. So this line is essentially saving some memory in the computer to for an integer array of size 3 by 3. And now let's take an input from the user. Now how do I do that? So let's just write enter 9 elements because that's the number of elements we're going to find. And then we'll start a for loop. Okay, now this will not work. So let's just do 3 here. J is less than 3, J plus plus. Now to print a 2D array, here we're taking an input, so Cn A of ij. Now what is going on here? Well, we have a loop starting. So when I is equal to 0, it's going to start, then j is going to be equal to 0. So then substituting that here, we're starting with the 0th element. Then we're going to go through the second element. So we're essentially, for a matrix that might look like this, we're sort of traversing like this across the matrix. We're going left to right and then down a row,